have a list of cars, for example, and this is a good example. You have a list of cars and you want to print out the name of each car. So remember, we've done the list, and then you have a list of cars and you want to print out the names of each cars. Car names are proper names, so the name of most cars should be printed in the title case, right? But notice they are not in the title case here. They are essentially, in the lower case. However, the value BMW, right, should be printed in all uppercase. So we have all of these. Some of them need to be printed in a title case. Some others need to be printed in uppercase. How do I deal with a situation like that? So we are saying that the following code loops through a list of cars and looks for the value BMW. When the value is BMW, it is printed in uppercase instead of title case. So that's what we have here, right? So we are saying for a car in cars, we already know what our list is. Our list is cars. For car in cars, if the car is equal to BMW, so I'm asking this program, hey, use the for loop through this list. If you find a BMW, because remember, strings are also case sensitive in Python. So if you loop through this and you see a BMW, print it out as a car and then apply the method, which is the upper method, so that it changes everything. What the upper method does is like uppercase, it changes everything to uppercase. Else, just print out the other cars with the title case, which is what you have here. Notice that they are small case. All of them are small case, but in this particular case, I want to turn this to completely uppercase, right? And then these, I want to change them to a title case, which is where your first letter is capitalized. So this is the code. So all I do is I run this, boom, and I have Audi, BMW, Subaru, and Toyota printed out like this. Does that make sense? Questions? If you're lost in any way, let me know. So in this place, what's happening is the loop in this example, what it does is first checks if the current car is a BMW. If it is true, the value is printed in uppercase. If it is not, so the other things, right? If the value is anything other than BMW, it's printed in title case, which is what's going on here. So I will check this. If it's BMW, I will do it in uppercase. But if it's not any other thing, I print them out in title case. So this is a place where I am running a conditional test. Now, and what I'm trying to do is to find out if a condition evaluates to true or false. The conditional test that we're talking about. And this is really very central to the if statement. Remember when I showed us the syntax requires that a certain condition be met, right? So Python uses the values true or false to decide whether a code is an if statement and therefore should be executed. If a conditional test evaluates to true, Python evaluates the code following the if statement. In other words, if that condition is met, then it would execute the next statement. What we've been using is it prints out something. It doesn't always have to print out something. It could do any number of other actions, right? But the important thing is that it is going to perform some kind of action if it evaluates to true. But if the test evaluates to false, Python ignores the code following the if statement. So because there is no else in the if statement, all it just does, it just stops and doesn't do anything if the first statement evaluates to false. So the first thing we want to do is to check for equality, right? So in this particular place, what we have is we know that car is equivalent to BMW, right? But we want to, so equality sign returns true if the values of the left and right side of the operator match. So in this particular place, right, car is equals to this, So we are now using the equality sign to check whether this is equal to this, right? If you do that, you find out in this particular case it's true. What if I changed it from BMW and I put something else? And I say Toyota, what happens? What would it initially it evaluated to true. What does it do now? It evaluates to false because the car here is not equal to a BMW. So I'll bring back my BMW and now I run it again and it evaluates. So the next thing to note is that it's actually case sensitive. So if you do this right, it's going to run to be false. Why? Because this thing is really very case sensitive. The quality test is case sensitive. So if I say A, all of a sudden it evaluates to true. But if I just change something slightly, it evaluates to false. So if case, like the case type, uppercase, lowercase, title case, and all of that doesn't matter, but you just want to test the value of a variable, you can convert the variable's value to lowercase before doing the comparison. So if case doesn't matter to you, you can literally apply the dots lower method and then run it, and then it will give you. So sometimes we want to check for inequality, right? So the combination of an exclamation point and an equal sign, right, can be used to determine whether two values are not equal. I did show us that in the previous class so this is an example. We are talking of, how you have toppings on your pizza, right? We know of the required toppings. We said the required topping, we want to put some mushroom, and we are running this if statement. If the required topping is not anchovies, right? Then print hold the anchovies. So in this case, right, it's not. That's why it just holds it. If it is not, and how do we test that proposition? We use exclamation mark and equals to. This is saying it is not equal to. Then we also have the comparison test. So for example, age is equal numerical comparison. Sometimes you can decide to do numerical comparison where you're saying age is equals to 18. Then you ask the question, is age sorry, and I keep saying this is not equal in programming, right? It's just mapping to. This is where you have the equality sign itself. Age, let's say age maps to 18, right? The age is therefore equal to 18. You are testing. This is what you use to test whether age, you see, you're essentially, when you have the double quote, you're asking, is age equal to this, right? So let's say this variable, right? We have 17 stored in this variable. We're now asking if answer is not equal to 42, then print this, right? And we can check. If you check, is it equal to? No, it's not. That means if this is not equal to, then print this. Same thing here. And you can, so these are all kinds of conditions that you can create. So we're just showing you, all I'm just doing here is showing us the different kind of conditions that can be created. Now, sometimes we have multiple conditions, right? We'll have to test this and also test this. Maybe there are multiple conditions to qualify for something, right? And I say something like, to get into this course, you need to have passed English 101 or English 102, right? So in that case, right, I will have to test two propositions, this or this. Or I can say you need to have passed this and this, right? So in those cases, that's where we begin to use your and or. So you may want to check multiple conditions at the same time, e.g., you may want two conditions to be true simultaneously to take an action. Otherwise, you may be satisfied with just one condition being true. The keyword and or can help you in these particular situations, right? So using and to check multiple conditions. Now, if each test passes, the overall expression equates to true. Now, if your goal is to make sure that both of them, so for example, let's say age of this fellow, let's say the first person, their age is 22, and the second person, their age is 18, right? And you said, okay, if age is greater than or equals to 21, and if age zero, which is age zero, is greater than or equals to 21, and age under age one is greater than or equals to 21. So you're testing these conditions, right? If it's true, then do something. If it's false, do something. But if we look at this now, we know that age zero, which is 22, essentially just act like you're carrying 22 down here. You're saying 22 is greater than or equals to 21, which is true. So you want this to be true, and right, age 2 is 18. 18 is greater than or equals to 21. That's false. So true and false would always give you false, and that's why we got false here. So if I create a condition like that, and I said if this happens, right, then do this, until I get a situation where both of them are true, it's still false. And the next condition and the condition under that if statement is not executed. Right? So then we look at this, right? Age 1 is equals to 22. Let's assume our age 1 all of a sudden changes to 22 now. Now our age 0 is still 21. So it will be 21 greater than or equals to 22, 21. Yes, that's true. And age one is now 22. You'll be like, 22 is it greater than or equals to 21? And which is true. That means true and true. True and true will give you true, right? So and that's what we have here. But see, to improve readability, you can use parentheses around the individual test, but they are not required. So in this particular case, we're able to do it without parentheses. But one of the things you want to do when you write your programs is you want them to be readable, right? So in this particular situation, we are creating a code that's, we hope is readable, right? And that's where you have this. So right now with this, you can now come atop this and say, if this happens, then do something underneath it. There are also conditions where you're looking for either or. So in those cases, right, if one of them is true, then everything evaluates to true, right? Because you're not saying and, it's just an or situation. I want either this or this. In other words, if either of them is true, then it evaluates to true. If both of them are true, then it is true. But if both of them are false, then it evaluates to false, right? So we go here. The keyword or allows you to check multiple conditions as well. And these conditions don't even have to be just two conditions. It can be multiple conditions. It passes either or both of the it passes when either or both of the individual tests pass. An or expression fails only when both individual tests fail. Let's consider two ages again, but this time we'll look for only one person to be 21. So we have the age of one, age 0 is equals to 22, age 1 is equals to 18, right? So age 0, what is our age 0? 22. So we're saying 22 is greater than or equals to 21, right? Which is true. Or age 1 is 18, which is 18 is greater than or equals to 21. Heck no, that's false. So that's true or false. In that case, we can go with true, because it doesn't require both of them to meet that condition. It just requires just one. So, but in this particular case, let's assume that our age 0 is now 18. If I come here and I say 18 is greater than or equal to 21, that's false. And age 1 is what? 18. 18 is greater than or equals to 21. That's false. So we have false or false is still false. Questions? Any questions? Okay, now sometimes we want to check whether a value is within a list. So we're looking at this required toppings is equals to mushrooms, onions, and pineapple. And we're really looking at a case of pizza. And then how in pizza you have different toppings. Someone can ask, add me some onions, some pineapple, mushroom, and all of that, right? But in this particular case, the person there is checking whether we still have a particular topping, right? And let's see how we evaluate it. So this is our first list. Let's consider some code that you might write for a pizzeria. We would make a list of toppings a customer has requested for a pizza and then check whether certain toppings are in the list, right? So we have these requested toppings are these mushroom, onions, and pineapple. So for the mushrooms, we are checking whether the mushroom is in the requested toppings, right? Yeah, of course, mushrooms is there. So, but notice that this in is a reserved word in Python, right? So anytime I'm trying to check something in a list, I can just introduce this particular word in. And what in just does is that it just checks whether this is within this. Okay. So let me give you another example. Let's say I come in here and I say what example would I use? Countries. Let me say African countries, right? And I start with Togo, Libya. Is that the spelling of Libya again? I don't know. South Africa. And then I say something like Ghana, right? So if I come in here and I'm trying to check whether Ghana is in this list, right? Let me take this out here because what we did before is influencing it, I believe. So let me create. Sorry, let me move this. Oh, just 1 minute. Okay. So I say mm, what is this? African. Am I not something? So Africa is equals to what's going on here? Ghana is here. So why is it not? Just 1 minute. Let me check one more thing because that's supposed to be. Oh no. So this is the mistake I made. Ghana in I was using requested toppings instead of African countries, right? So you see how that evaluated? Sorry. So African countries, blah blah blah. Ghana in African countries, true. But if I go write something like Nigeria, obviously Nigeria is not in the list, then it evaluates to false. So same thing is the same thing that is going on here. So I'm going to delete this, right? So in just helps you test that proposition whether a particular thing is there. So we also check whether pepperoni is in this list, but it turns out pepperoni is not in this list. So that's why it says false. So we can also have another way of checking whether something is not in a list, right? And that's the keyword that is used in Python to do that for a list is essentially not in. And that's why you see it's green. It has a specific color green, right? And you can tell that some of these are reserved keywords from Python because their color is kind of green. All of the reserved words, their colors are this. So sometimes it's important to know if a value does not appear in a list, you can use the keyword not in situations like this. For example, consider a list of users who are banned from commenting in a forum. Let's say there's a forum, all the people, each time somebody creates an account, we add their name to a particular list, right? And if I want to ban them, I can also ban them. So, and when I ban them, I now create a list of banned users, right? So let's say out of a million people, I have banned 3 of them and I put them in a banned list. And then each time that person logs in, right, I check to see if they are banned. So this is the banned list. And now I have a user. So I can write a code where I say if the user is not in the banned list, then print out something. And in this particular case, we have Maria. Maria, you can post a response if you wish, right? If Maria was in the banned list, you know, now that's when you need your if else, right? In that case, in the if else statement, it will now say something like Maria, you cannot post, you have been banned, right? So, but again, we are still in the if statement, but this is giving us an opportunity to introduce all the conditionals and all of that. So this is your Boolean expression. A Boolean value is either true or false, just like the value of a conditional expression. So the conditional expression and the Boolean, can equate to the same thing, but they are not exactly the same thing after it has been evaluated, right? Now, Boolean values are often used to keep track of certain conditions, such as whether a game is still running or something of that nature. So Boolean values provide an efficient way to track the state of a program or the condition that is important in your program. So I say something like, we are trying to check, is our game active? You say true. Or can I edit? False. So this is another way where you don't even have a condition, but then you are just setting specific parameters using Boolean values. So these are some examples that you can try and play around with. You have this assignment here. So then I go to if statement, right? The first understand the conditional statements, then start writing your if statement, right? So we have this particular thing where the age, let's say we have a variable representing a person's age and we want to know if the person is old enough to vote. So we say something like the age of this person is 21, and then we want to test if they can vote. If their age is greater than or equals to 18, you are old enough to vote. So in this particular case, if you test this condition, it becomes true. So this talks about the indentation that I already talked about so many times. And then look at another condition, right? If I have something like this and I introduce as many, you know, um, if I introduce as many things for it to execute, right? It's going to keep executing them provided they are indented under all of this. So let me just copy this and just uh, run this first so you can see it's printed 2 lines. But if I add in more things, right, then it's going to print 4 of them. See, but then all of them are subject to these conditions because they are indented to it. If I go back, right, I just need to click my tab and then it goes there. You can try that too when you're working on this. So from there we go to our if-else statement, and of course you've already gotten a gist of what we mean when we say the if-else statement sometime about this time, because I've alluded to it so many times. So if your age is greater than or equals to 18, you're old enough to vote. Then the next question is, have you registered to vote yet? Right? And we can also include a user input where the person can actually respond yes or no to. But that's not the subject of this particular point. But this is what we have, right? So if the person, if their age is greater than or equals to 18, it's going to print you are old enough to vote, and then it will ask them, have you registered to vote yet? And that's what you have here. So if we run this, that's what we have. But what if they are when we test this greater than or equal to 18, it's false. So let's go put something there. Let's say that person is 12 years old and then they run it, right? See what happens now. You say, sorry, you are too young to vote. Please register to vote as soon as you turn 18. So we've created those two conditions. If this is not true, then this should be true. So the person is 45. You also apply, you're old enough to vote. Have you registered to vote yet? So it says the if else structure works well in situations in which you want Python to always execute one of two possible actions. In a simple if else chain like this, one of two actions would always be executed, either this or that, in a situation like that. But there are certain times where it gets a little more complex. It's not just, so for example, you have a situation where they have a condition for people that are below 18, and then for people that are old enough, and then you want to give special concession, right, to people that are above 60 years of age, or they're above 70 years of age, senior citizens, and you want to have different conditions for them. The point is, how do you do that? And that's where you have your if-else, elif-else chain, right? So what do we have going on here? We have, let's look at an example. Consider an amusement park, right, that charges different rates for different age groups. Let's say admission for anyone under age 4 is free. Admission for anyone between the ages 4 and 18 is 25. And then we also have admission for anyone age 18 or older. Then we're 18 or older get to pay $40, but between 4 and 18, they have to pay $25. How do you execute something like that? Because certainly your if statement will not work here. Your if else statement will not work. And in this particular case, that's where you have your if else, right? So this is an example of what we mean. Let's say somebody presents, and the person, their age is 18, and then I enter their age in the system, right, so that it can print out the right receipt for them. So what that program does is that it will say, okay, if age is less than 12, and it's checking this age, that will be 12 is less than 4. That's false. So it skips it and goes to this place and does another test. It says 12 is less than 18, which is true. So it prints out $25, which is what it has done now. But what if I say that this person's age is 80, right? See what it does. It now prints out $40 and no longer $25. What if the person is 60, right? Guess what? It prints out $40 too. We can also go ahead and add one more line where we are thinking of people that are older, senior citizens. Maybe we want to charge them as more a different amount. Instead of charging them 40, we want to charge them something, and that's where you introduce another else if here. Sorry. what did I? Oh, I've posted. That's not what I'm supposed to. Yeah. So I was trying to copy this. No, I can come in here and then I can throw in something here, right? And then I will decide what that condition will be, right? So I'm probably saying greater than, if I could say something like, oh, this is probably better going to be, your condition is, I'm going to essentially mess up this whole thing, but so let me just probably copy it here. And then we go in here and just drop something here. Let's run that differently so that I don't mess this whole thing up, right? Or I think, do we have an example like that? Yes, we do have an example, so no need to do that. So this is what we have here, right? So we're going to see the particular type of example I was referring to. So this is another example, right? We could actually notice that in this particular case, in each particular condition, we are writing out what it needs to do, you know, the what needs to be executed, but we don't even have to be this verbose. And the way you do it is you use your F string, if you remember your F string, right? And we can essentially just call price, you know. So where we do something like this, we say if the age is less than 4, right, then we have a certain price is equals to this. Else if the age is less than 18, we have a certain price. Else we now say price is equals to this, and then we can say print. Now it's relieved us of the need to keep writing all of these statements, you know, and just use one print statement, right? And then what do? We just say use an F string, your admission cost is, and then we write in this, right, which is a curly brace that has the price. So in whenever it becomes true, it pulls the price from that particular line of code and then it writes it here, which is why we have this. So if my, now notice is $25, what if my age is all of a sudden 80? It's no longer going to be 25 and then it does 40, but you were able to achieve that with just one line of code. So I'll go back to my 12 and then we go that way. So we look at where we have multiple if statements, which is what I was trying to do the other time. So we have a situation like this where we are now introducing, oh, if someone's age is less than 65, we do this, right? But any other person above 65 will now go to the else statement, right? So we try for a 12-year-old, right? Then what happens? 25. So for anyone below 65, right? So let's try something like 45 and see what happens. You see, we get 40, right? What if we try something like someone that's 80? We now get 20, right? So different conditions. If the age is less than 60, 65, we get that. But once the person is 65, boom, they pay 20 because this is less than 65. But anything from 65 and above, if you're 200, 300 years old, now you pay 20 because it's senior citizens price. And that's how your multiple if-elif statements can work, right? But there are also certain times when you might decide, notice that there is an else here, you might decide to actually eliminate the else statement, right? Python does not require an else statement at the end of an if-else chain. It really doesn't. So in that case, if you get to that point, right, and there's something, it will just do what it's supposed to do without even doing anything. So greater than or equals to this will give us this. Python does not require an else block at the end of an if statement. Sometimes an else block is useful. Sometimes it is clearer to use an additional if else statement, right? So notice in this particular place, we are saying it is greater than or equals to 65. So anything greater than, including infinity, right, qualifies for a price of 20. So in a situation like that, it doesn't really make logical sense. There's really no requirement to use an else statement. So this is just saying that Python would also accept that. What else do we have? So we've done, there are multiple testing conditions. So let's go try the pizza thing that we were talking about, right? Where you have requested toppings is equals to mushroom and extra cheese, right? So I'm asking if mushroom is in the requested toppings, print this. If pepperoni is requested toppings, print adding pepperoni, right? If extra cheese is in the requested topping, you print adding cheese, right? And then you come in here, finished making your pizza, right? So all I'm just doing here is I am making it, I'm testing, right? Before I send it to the people that would prepare the meal. A customer has requested these particular things. And then I'm running through a list, right? And I'm checking. If this is requested, add it. If this is requested, because these are all the offerings I have. I have pepperoni, I have um, mushroom, I have extra cheese, but this is all they have requested. So it's just going to run through that existing code that you have on that program, right? It will check if this is requested, print adding this, adding this, adding this. Could be 20 different things. It will just run through them quickly, right? And just pick the only ones that were added. It says adding uh mushroom, adding extra cheese, and then this printout. Notice it's on the same line as the if. So it's not affected by whatever instructions are given here. It says finished making your pizza. And then you print this out, right? Now, but notice it said this code would not work properly if we used an if-elif-else block, because the code will stop running after only one test passes. Here's what that will look like. So if we had used the if-else statement, right, it will just run through. Once the first condition was true, it will stop, which is what your uh, if-else statement will do, right? So something like this. Look at it. If this is in this, you print this. Else if this will not work. So the first thing it does is just prints only the first thing. So the fact is you need to know when you're supposed to use one particular, you know, control structure or the other, right? So the next thing we're going to do is actually now using the if statement, right? To do things within your list. And we've been talking about the list for a while right now. So it says you can do some interesting work when you combine list and if statements, right? You can watch for special values that need to be treated differently than other values in the list. You can manage changing conditions efficiently, such as the availability of certain items in a restaurant through a shift. You can also begin to prove that your code works as you expect it in all possible situations. So let's look at this particular case. Let's continue with our pizza example, Pizzera example. The Pizzera displays a message whenever a topping is added to your pizza as it's being made. The code for this action can be written very efficiently by making a list of toppings the customer has requested and used to loop to announce each topping as it is added to the list. So we have the requested toppings. So this is essentially your list. Remember, you know your list is here because it's a square bracket. If it's in your parentheses, that's not a list. You know, that would be more of a tuple. But square brackets is what makes it a list. Now you apply your for loop, right? You said for requested topping, right? Which could be any of these elements within toppings in toppings. So I'm saying for each element here within this, right? Print, and then I use my f string, which is just say adding, and then in quotation marks, I point to the variable that I want, which is, sorry, I point to each of the elements, right? Topping. Notice this is S, and just this is just topping, one topping, each of the toppings. So you say adding this, and then with this I can loop through everything that is here. So if I add even more things, so if I run this right now, I have this. So what if I added more things and I say ham, right? And I say what else? Onion, and I say cabbage, right? Same thing. Once I run it, it gives me everything that I want, right? Just because I used my F string and then I put my variable in curly braces, that way it just goes there and pulls whatever values. So that's a very efficient way of running a system like that. So that's what we have. And then it says finishing making your pizza. Why do we have a line here? Is because of the /n, because that /n just says new line. That's why we have the line. And then why do we have this on its own, right? Because it's on the same line with f. So the instruction here does not apply to it. But what if the pizzeria runs out of green peppers, right? An if statement instead of a for loop can handle this situation appropriately. Yeah. So we run out of a green. Here we have green peppers. What if we run out of green peppers, right? And we want to, because sometimes we run out of these things, right? So we want to be able to set up a situation where if it's not available, we quickly communicate it to the customer that it's not available. So customer is asking for mushroom, green peppers, and extra cheese. Now, so we write a code with this, right? Where we said for your for still helps you loop around each of them because you're checking for this within this. And I now use this if statement. If, you know, but notice what's happening here, right? I subordinate my if statement within this, and I says if the requested topping, is equivalent to green peppers, right? Print, sorry, we are out of green peppers, right? Else you print this, so because f, right, is subordinated under f, this f is going to apply to everything here, right? So it's going to run all of this here before we move to the next thing. So which is what you have going on here, right? And then else add this, right? Boom, and then that's how we get this too. So essentially, and then you can also do multiple lists. Let me run this first. Sorry, just 1 minute. Let's run this. Checking. Yeah, good. Look at this. Sorry, checking that a list is not empty. Now, it is possible that a list might not have any item in it. So there are certain times when a list doesn't even have anything in it, right? Some lists might just not have anything in them because we are waiting for the users to provide the information that will be stored in it. So we can't assume that a list has any item in it each time a loop is run, right? Therefore, it is important to check whether a list is empty before even running your for loop, right? So as an example, let's check whether the list of requested toppings is empty before building the pizza, right? So you start with requested toppings and then it's empty. This is a null list or an empty list. If the list is empty, we'll prompt the user and make sure they want a plain pizza, right? If the list is not empty, we will build the pizza just as we did in the previous example. So look at this particular situation, right? So we are starting with a null list. If requested toppings, right? Then we stop there. For requested toppings in toppings, print, and then you use your F string, requested topping. Then you print, you know, finished making your pizza. Else, are you sure you want a pizza, a plain pizza? So this is in a particular case of a plain pizza. This person doesn't want a topping. How do we figure that out, right? And that's what's going on here, right? For requested topping in toppings, print, adding requested topping, else, print, are you sure you want a plain pizza? So let's run it. Are you sure you want a plain pizza? Why is it saying, are you sure you want a plain pizza? Because it has gone in there and there's nothing there, right? So it's a null set because it can't find anything. So this is false. That's why it now went here, right? So let's also go to the next one where you're having multiple sets. What if a customer actually wants French fries on their pizza? You can use lists and if statements to make sure your input makes sense before you act on it. Let's watch out for unusual topping requests before we build a pizza. In this particular case, someone is asking for French fries on their pizza, right? So to do that, we are creating two different lists. Notice that this is available topping. Initially we were just focusing on the requested toppings only. But now we're trying to include the available toppings versus the requested toppings, right? So that when we have the requested toppings, we actually check in the available toppings whether there's the topping you're requesting does exist, which makes more sense, right? So notice the first list is called available toppings, and then the second list is the requested toppings. Now it says for requested toppings, right? In requested toppings, if the requested topping is in the available topping. Now you're checking whether what's in this is available in the requested topping is available in the available topping. So you print this out, right? You print out the requested toppings. Else, print, sorry, we don't have the requested toppings. So that's an example here. So this is the requested toppings. This is what the client has asked for, but this is what we have. So we use a line of code like this, right? So if the requested topping is available, right, we say print this, but we have to check first for requested topping in toppings. So this is our requested topping in topping, right? So we have this. The next thing we do is we now use an if statement. If the requested topping, which is 1, 2, 3, is available in the available toppings, right? What we have is this, but there is no fries here. So that evaluates to false, right? Else. So because it's false, it now goes ahead and prints sorry, right? But remember, it's looping through each of them. Because it's looping through each of them, it tries each of them. So the only available ones that it has is mushroom. That's why it prints out mushroom, and then extra cheese. It prints out extra cheese. Because it didn't find green, it says, sorry, we don't have extra cheese.